Oh, this is very interactable. I didn't know that. Wait. What the? Okay, I have a thunder machine. What happened to my aloe plant? I did buy it, didn't I? Oh, I can only have one type of plant. I mean, the cactus protects me from radiation, so I'll keep that. I didn't know that was a thing, but apparently it is. Okay, so we have finished all these missions. Now we have Dawn of Civilization. You've reached the end of the epoch. Click one of the banners to proceed further in the story. Bronze, silver, gold. Okay, here goes nothing. Dog. Nothing much, really. Cat has been detected? No, didn't work. This should work. Almost did it, almost. But didn't work. Oh. Wait a second. Well, we do have the gold. I think. Oh no. Cat biology iRobot. Cat mail. This should definitely work. Cat, Eureka. We got it. Cat has been detected. Okay. I guess that's because we got gold medals all around. So I managed to make my computer detect a cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go to the next level and start recognizing emotions. Or the perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. Double helix, the rock and roll, the lava lamps. Also, you can maybe switch to dogs instead of cats. Decision trees work like magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree, you know? And now for something completely different. Perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. Percentage of errors is shown on the icon. Use training mode to teach perceptron and decrease the amount of errors. In training mode, perceptron reduce the amount of errors while trying to predict the shape of the elements. In test run, perceptrons only predicts shapes. Right, so we put a perceptron in. That should go there, that should go there, and that should go there. So we train it now. And it lowers the percentage of errors. The nodes in the field have reached their minimum margin of error. There's nothing more you can teach them. Really? So 20% is just, I guess, what I have to accept from now on. Okay. There's going to be some degree of error from now on. Sure, why not? Dairy products. Hello, my name is Sam. I own a dairy product factory. My dream is to make my very best goods on the market, and that's impossible without high accuracy in fermentation processes. Of the fancy words, when the program that would judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory since we mark them as defective. We have the data, we need the algorithm. Okay. Oh boy. Well, I mean, technically... Okay, so if we do a test run, I mean, that seems fine. Never mind, not even close to being fine. Why is that? I have to use 2, it seems like. Maybe we send this one in here. And we do like a double filtration system to catch more errors. Basically, of the 20% misfires, only another 20% of the 20% really misfires. See? That's how you do it. Metal Gear construction. Oh boy. Hello, we're the Metal Gear Construction Factory. We produce fittings and supply raw materials to construction grounds all around the world. We're especially proud of our high standards quality. We are definitely not building a giant death machine. At the moment, we're receiving a lot of new orders and we are running late on with the deadlines. An algorithm is required that will analyze the quality of raw materials and discard poor quality ore before it leaves the conveyor. Manual analysis takes way more than we can afford, and our Metal Gear is not going to build itself, okay? Oh, for fuck's sake. What am I looking at? Well, I need a trash can, I think. We need to be able to send red triangles in the trash. So, okay. They should go there. And these should go in the trash. Let's do a training session and see how it goes. The Mark 1 Perceptron is bottlenecking real hard. Because it's getting the stray greens. I think this might be better. Okay, that Perceptron now is a little too... But it doesn't matter like how bottlenecked it is if this is actually reaching the correct amount. So let's do a test run and see how it goes. We don't have a lot of time, to be fair. Yeah, we are out of time. Wait, the fastest system. This blue one has to be sorted. I'll tell you what. I'm gonna put another decision. And we're gonna redirect all the greens basically to this one. And the blues in there. And the triangles go in here. And these ones are going into the trash. So we have... It's not fast enough. I mean, it works, but it's not fast enough. So how do we fix that? I don't think I should filter for triangles before. I know the faster things have to be put before. Blues, by the way, are in way higher quantity. So it makes sense that blues have their own system. Red and green combined are not as big as blue, so maybe they can both use the same pipeline? Ah, but this is trashing the triangles. But that doesn't matter, it's only 10. Not that many. Wow, not even close. Accuracy is through the roof, so maybe we care a little less about accuracy on certain items. You know, I think the problem here is not care so much about accuracy as speed. We have literally no time to do that. Holy shit. Maybe we are looking at this wrong. Maybe we should sort the green and the reds. And so blues go kind of everywhere, but blues have to go only in triangle mode. We can have this basically sorting the blues out. We have so little time. Oh, not even close, dude. Do I just not sort the red? That looked a little bit better, I think. What? Good question. I don't know. Less red we care about. Do we sort the blues and the green instead and let the red go? I think that might actually be it. Because, okay, if I sort for blue and green, we're gonna have some red coming in here. Same goes here. We're gonna have some red coming in here. Maybe this thing that makes you go cross-eyed actually is better. It's bottlenecking because I'm using both that and the blue and the red. Why would I do that though? Or why not just sending all the reds in here and the blues there? This is red only, that's blue only, and this green only. It's not fast enough again. Can I just send the reds directly in from both sides? And this is useless. And fuck sorting the reds. Because we're going to get the accuracy anyway. Dude, that felt like it was so close. Wait, hold on. If I do... Oh no, because the blues are going through anyway. And there's so many blues. The blues go down here with the reds. Sorry, with the greens. We cannot have like a perceptron to do all of this, right? Why would I even need this? And I'll just send... Oh, because of the greens. Well, I mean, the arrow... Well, let's just take a look. So there's some greens in, but I think we're going to still reach the 60%. Genius. We don't give a shit about the greens. We still have enough accuracy to do it. Alright, release the product. RNG is my best friend now. Or so they say. Okay. So what's the next objective? Let's see. Toy manufacturing. New technologies in toys manufacturing. Howdy! I'm contacting you on behalf of Nuka Toy Company. The design and manufacture toys that are definitely not radioactive for children's using 3D printing technology and definitely not uranium. There are 3 types of raw materials we use for printing and we need an algorithm that would distribute them correctly. Let's get certain errors threshold could result in disaster, so watch out for those. Okay. Oh, Christ almighty. Can we just not... just not do that? This cannot be that easy. You shouldn't just be sending data from input to output, you know. Come on, let's sort some data. What do you mean? That works. It doesn't need sorting. Are you for real? Fine. What if I do it like this? It's gonna take too much time, I bet. I see the problem now. Circles have to go up there because we don't have enough circles on one of them. 30. That should be plenty. We did send enough circles, we actually didn't send enough down here. Let's send the triangles here and these triangles here. That's a better proportion, I think. Not fast enough there. Oh. 22, 35. I think I have to send... I have to send them through another perceptron. We need to catch the strays, right? Less error means more of those. But that system should lead to less errors, I think. Even though it seems like a lot of circles are going in there, but that's just because we are not trained the perceptions enough. The perceptrons, even. It's not better, is it? Not at all. I think I really need to work with the numbers here. Don't have enough triangles. We need these to go down there. We need them to go here. What is going on here? Dude, what, am I dumb? I completely forgot an output. Alright, now it should work a little better. Let's see. Can't believe the system is still misfiring. We are not filling this one fast enough. But now we fill this in 5 seconds and we didn't even reach a quarter of that. Oh, my brain hurts, guys. My brain hurts. Scrap it. Back to the beginning. We only send circles up. If we do, it means that we have to send the least amount of everything else in there, which means the triangles. And some stray squares. Then we send everything down there. All the squares. Is this gonna work? But then this one, what is it doing? It's only getting triangles from this one, which is not enough to fill it. Which means we should send the triangles there, the squares there. But I feel like I tried this system and it wasn't working. They're filling almost equally, but just not in time. Say, hey, 20% is a good percentage, so fuck it. Accept the errors. Now this is gonna fill too quickly and this is not gonna fill enough. Oh, it's close. Do I send triangles directly in there and basically do the same thing I did in the other one? I say fuck it. Catch the strays, it's fine. Our percentage is still mostly fine. I mean, it is better, but I need more stuff going down here. The thing is, this has to be 100% accurate, so we cannot send random ones. They have to go through the double perceptron. No, never mind. It accepts everything, so I can just... I don't know, do something like that. The middle one is not filling enough now. Motherfucker. Send the triangles in directly. I said I want the triangles in directly. Wait, is anything going in here? What am I doing with this? Oh, man, I was so close. We need more down there. What more can you possibly want from me, though? We send the circles down. We catch some stray circles. The 20% that doesn't make it there goes down here. Maybe that's gonna be enough. So fucking close. I mean, it was close enough to finish it. Dude, 44.6. I am 0.6 seconds off. I need to do a test run and I need to see which one is causing that 0.6 seconds of delay. It's this one, isn't it? Yeah, it's still the bottom one. What if I add another perceptron? Some of the stray squares and triangles that are going up this way, because you know there's a 20% chance, and we'll resend them down in there. Could that be the extra step that we need? Got one. I mean, I got two. Holy shit, that was it. Okay, sometimes I do be smart, okay? Sometimes. It takes a while, but we got there. And I made $1,000. And now, I have just enough money that I can't buy anything. No, never mind. Oh my god, guys. At least I get there. Exactly. We can buy a propaganda poster. We can buy a hairstyle. Jesus Christ. What have I done to my hair? I feel like that's worse, but... sure. We are going to do text recognition. But whether you were able to create a text recognition system based on Rosenblatt perceptrons with a similar system, but that would also be able to distinguish vowels from consonants. The task is simpler but more accurate. Okay. Rosenblatt perceptron. First perceptron machine neuron was invented by Frank Rosenblatt in 1957. Creating the Mark I in 1960. Mark I is a perceptron machine that can recognize English letters by their shapes. Damn, dude. You know, I feel like this is the coolest part of the game. Seeing all these historical things. I'm sorry, how is this? Oh, I don't get it. It's just one. And I didn't really have to do anything. I'll take it. Shed the state quite about being smart sometimes. Maybe. But now, we do RL0. Reinforcement learning. Hello. We is a society of peoples who loves cats. We want our cats to has all the best. We want cats to drive cars with no humans inside. But cats have no hands, cats has paws. Can you make a car that self-drive? Yours, Dr. Meow W. Cat's human person. Yes, please excuse our grammar. We are not cats, we are humans, but we can't type well because we has paws and no hands. Terrible car accident, bad surgery is why we need a self-driving cars, haha. Definitely not a cat. Okay. Oh boy, what is this? Recognizing objects. In reinforcement learning task, notes work with a bit of different way. All data is initially unspecified and your task is to recognize it and transmit it to RL agents, the AI. Gets the unrecognized data on the input and classifies them as either an object or as a road. Okay. So does it become better over time? Training model. On this screen, you'll be training and testing your own AI. Excuse me? AI acts basing on data you've been recognizing when building your scheme. The data about surroundings on the road are processed from your scheme to machine learning model. Your car won't be capable of learning and detecting without obstacles. Sorry, detecting obstacles without it. The goal of this type of task is to make the AI clever enough to be able to reach the target average speed level. Supervised learning and drive the truck yourself is in WASD to teach the AI. Oh boy. Be careful, the car sees only objects inside a LiDAR area and only learn from them. What the Fuck am I? Wait, I don't know what's happening. Press training and watch the car's AI trying to reproduce your actions. We hope you've been driving safely in the supervised learning stage. It's training to proceed. Well, let us achieve the target speed level. Let's test and enjoy your result. If the result isn't good enough, try the car again. Holy shit. Okay, can we all agree that I have got the gold star, but I have absolutely no fucking clue what I've just done? Are we all on the same page? All over that with this one? Hi, we're trying to launch a self-driving... Oh, I have to do a startup. I'm about to invest 4,000 euros in a startup. Are you sure you want to do this? I am not. You don't need to train your nodes while working on a startup. They already have the minimum error margin because time is money. 85.90. Okay. Is this good enough? It's apparently not good enough. Okay, now it's staying above the 85 over there and above 90 down there. Seems good to me. Release it. Deploys the code to the servers. Okay. Self-driving car. Let's see how well it's doing. Doing very well. It's not always possible to satisfy all customers in one day. Usually the unfulfilled requests are shown in red colors. You don't have the instruments to solve this problem for the startup, but you get some to handle the future ones. I mean, I'm making money, I think. Users are dropping. Oh, goodbye. Sell it. I made 6,000 bucks and then I sold the company. I think I just scammed a bunch of people, but I don't care. This game is teaching me that's how you do startups. You basically make something, you ride the popularity, and before it crashes, you cash out and sell it to some bozo. Yeah. Parallel calculation. We are learning load balancing. Okay. Hello, we represent a scientific center. Our current programs are underperforming. Can you parallelize our calculations? I was born to parallelize. To process data, your nodes need computing power. A server. So nodes require more than one server. The more servers used, the more expensive your schemes become. It's routing elements to the least overloaded socket. So this is what I wanted. I wanted a 50-50 split, and I think this is what it does. Yeah. If you can pronounce parallelize correctly means not all the brain has leaked out yet. I guess so. That's good. But there's still time yet in this stream, so we might be looking at a kind of late leak. Increase sockets processing queue by 5. Don't know what that means, but I'm buying it. Increase service cost. Buy it. Alright guys, let's do some large parallel calculations. A parallelization system broke after the last Doors OS upgrade. Can you fix it? Sure. Deep news. The darkest years of machine learning. In 1969. Nice. Simo Papert and Marvin Liminski wrote a book called Perceptrons. In this book they spoke about the math constraints of the first perceptron, the XOR problem. This book has shifted scientific interest and funds distribution from the US government organizations, slowing down the progression of machine learning for almost 30 years. Jesus Christ. The expanded version of the book was released in 1987, containing chapters that disprove the statements from the critical remarks made in 69. I see, so they fucked up. Easy peasy. Dictatorship. Let's do secret information first. No text here at cat.meow. Good day to you. You're a secret military organization. Our codename is Protoss. Everything you're going to read further is classified. Our analysts are sending operatives to various war zones. An escalation of conflict with the enemy has recently occurred. We are in need of self-learning algorithm capable of sending dedicated units to respective parts of the battlefield. I am building a StarCraft bot. Gotcha. Oh my god. We have 30 and 90, which is 120. Over here we have 130 130, I believe. 60, 60, 120, 127, 130 something. Okay. 35. Which means we mostly need to split this like so. I think. Because this is 60-ish. And this is 30-ish over here. Cool. Obviously, we have a problem because we cannot send the greens there. However, the expert system sorting the greens is too slow, so we can't use that. I think what we have to do is sort red and green and not care about the blues. Now the greens can go straight in, and then we split the reds. I guess the problem here is that this is going to be bottlenecked. Well, let's test it. Absolutely, that's the problem. Yes, bottleneck. Not fast enough. So we need a balancer. We split it. I'm using too many. We don't really need this balancer because we're already sending half of the reds there. Oh my god. I didn't put that in. Okay, try again. It's still super bottlenecked. Not good enough. Okay, that wasn't too bad. Right, we can buy new things. What can we buy? A Javadia 250. Holy, increase work speed by 3%. Another server. And a 30 gigs hard drive. I don't know what a DLL slot is. Well, I'll buy it. Cyber Initiative. Greetings, our company's cyber initiative is into manufacturing androids. Our production lines are fully robotized. The only function which is still performed by human workers is logistics. We're shipping our androids to the government, military companies, etc. We'd like to automate the process with an algorithm that will distribute androids depending on their characteristics. Glory to the robots. I have 110. This needs 50. So roughly half of them have to go that way. This is 50. 25... plus something, and the rest here. And that's good. First of all, it needs to be split. Don't know if this is good enough, but I feel like we need to crash the green, send everything else in the balancer, and then distribute them equally. Although I feel like it's going to send some blues in there, which is a problem. I mean, the obvious solution would be to trash the greens and then send the reds up and the blue down. That's not going to send enough reds in there. I'm gonna just do a test run, but I don't think this is gonna work. Okay, we have more than one problem. If I could send the red and green up above, and just the... I can't send just the blues down, I need some reds too. Oh guys, this is a tough one.
A few moments later.
Am I sending too many blues down here, by the way? I think I may be. Definitely, look how many. We send at least another like 5 or 6 extra blues. Did I do anything? No, because I fucked it up. I'm sending some reds in there, some greens even. And it didn't fix the amount it needs to go up there. Wait, can I send that like a double? There's just no way this works. This is sorting for greens. Where are the greens coming from? Wait, what? Oh, it's not the greens, it's the blues. Yeah, it's sending half of the blues in there. Okay, what's missing? Maybe we can send those half the blues somewhere else? This is getting nowhere near enough. Shit. And that doesn't get enough. Oh my god. I think this is it, guys. I think this is the one that kills me. This game, I'm like halfway through the game, guys. I don't think I'll be able to ever communicate with my cat, but it was a good game. I had fun playing it. It's nice. It's a good game if you're into like programming, I suppose, or like machine learning and that kind of stuff. It's really complex, and I mean, I could probably sit here for hours and hours to find the proper solutions for everything, but I feel I don't have that kind of time, and I kind of want to move on. So I'm gonna call it for Wall True Learn. Pretty decent game. Well, you definitely need to be very, very smart, I guess, to do this properly. I would say, like, I'm going through it by trial and errors, basically. But there's probably a better way to play this game, right? like actually understanding everything about what you're doing. I do vaguely understand it, but not enough to be good at it, I think. But it is difficult. It's like high degree of logic, isn't it? Cool stuff though, cool stuff.